Meaning of the differentiation. Differentiation is a method of finding the derivative for a function at any given point. In calculus, derivatives is the measure of how a function changes its value as the input changes. For instance, suppose y is a function of another quantity x. For an example, y equal to fx. When there is a change in x, y also changes according to the function fx. In order to find the rate of this change at any value of x, we must find dy per dx at that particular x. Why we use differentiation? First, find rates of change. For example, it allows us to find the rate of change of velocity with respect to time, which is acceleration. Second, find the rate of change of x with respect to y, which on a graph of y again x is the gradient of the curve. Third, determine the maximum and minimum values of particular functions. Example, cost, strength, amount of material used in a building, profit and loss. And the last one is differentiation can help you tell whether a function is increasing or decreasing.
A conical water tank has a radius of 3 cm at the top and 15 cm height as shown below. Water flows into the tank at a rate of 6 cm cubic per second. Question A. Show that the volume of water is given by V equal to pi h power of 3 over 75. Question B. How fast is the height changing at an instant when the height of the water is 5 cm? Question A have been solved. So, we look to the worksheet. This equation given from this question A. Okay. From the question gives us h equal to 15, the height of conical tank. So, we substitute h equal to 15. We put it into the calculator and we get the answer. Let's solve question B. The water flow rates is given from the question. dV over dt equals to 6 cm cubic per second. And then what we're going to find is dH over dt when h is 5. This is the equation formula to get the answer, the final answer. This is to find volume of the conical tank. Okay. First, we're gonna do the ratio method. The ratio method is, this is radius over height, 3 over 15. So we simplify the equation, this equation into this equation. So from this equation, we got R is 1 over 5h. So we substitute into this equation like this. This is R, radius square. So we got V equal to 1 over 3 pi multiply 1 over 5h square multiply h. So we simplify that into this. and we got this. Then we convert into this equation from this multiply with this times 3, and this we minus 1. So it become like this, dv over dh. So from that, we can get we substitute again into this equation. So it became like this, dh over dt equals to bracket 1 over 25 pi h square multiply 6. 6 is the water flows rate. So this, it become like this, and then divided into this. When h equal to 5, dh over dt equal to 6 over 1 over 25 pi 5 square. So we put it into the calculator and we got the answer. This is the final answer.
My name is Muhammad Hanafi bin Ahmad Nizam. Current matrix number is 2019-237958, and I'm from group RAS 1132D, and I'm here to solve this problem. So first of all, they ask that when the depth of the water is 60 cm, find the rate at which the depth of water is increasing. So they want a rate of the depth. So we put here dh over dt. So it's equal like dh is equal to dt, and this dv, and this is dv. Okay, clear. Okay, first of all, we need to know this is the cone, and they say this is a 45, this is 45, and this is automatically h, the water is filled in the cone is equal to r. So r is equal to h. Okay, the cross section of the cone is a right angle isosceles triangle, and therefore r is equal to h. Hence we can say this v is equal to 1 over 3 pi r3, but we need to find dh over dt. That's the question they want. Dh, rate of change of height. Dh dt is dh dt over dv, and dv. Okay, so we can conclude this 1 over 3 pi r pi h 3. So we need we can say this is v. Okay, so this is v, this. Okay, first of all, we need to find this first. We don't know dh, but we can find this dv first. So dv is equal 1 over 3 pi h3. So first, then dv dh 1 over 3 and pi h3. So this gone, and okay, So the answer is pi h square. Okay, now they want this dh over dv, so we just do so the answer is this 1 over pi h2. Okay, then dv, the rate of the volume is given, because the example say an upturned cone with semi-vertical angle 45 degree is being filled with water at a constant rate of 30 cm square per second, cm cube per second, I'm sorry. So we can say dv per dt is 30. Okay, so we found this, we just do 1 over pi h2 and 30. Okay, so the answer is 30 over 1 h square. Okay, it's not over yet. Let's say when h is 60, so we have dh over dt is equal to, we just put this 30 over h 60 square pi. So the answer is 1 over 120 pi cm per second. Second question is, we have seen that R equal to H, so we can say this, we have that R is equal to H. So when R is equal to 60, we have dash d r per dt, and the answer is same. Because we from the start we know R is equal to H, because the cross section is same with radius equal to height. Number 3, the question number 3 is, they want ds over dt. So the formula for area of the cone is pi over pi r2. So therefore this ds over dt, ds dt dv over dv. Okay, I'm back, and yes, we can make this easier. So we put this ds over dr and multiply dr over dt. So we get 2 pi t and equal 33 over pi t square, and then therefore we get 60 per r. Okay, but and when h is 60, we have r also is 60, and so ds over dt is 1 cm per second. I mean 1 cm cube, 1 cm square per second. Okay, that's all from me. Thank you.